Hi and good day everyone. Welcome to Hosey How to channel where I share real project experiences for better skills that will lead to higher pay career. Today I would like to share with you, pipe material roughness impact on the pumping system. There are many types of materials used to transport fluid from one point to another. For pressurized pumping applications, steel, polyethylene, GRP, iron, copper etc. are used in the construction industry. Different material has its own benefits and weaknesses depending on the type of application. How these different piping materials will affect the pumping system. Before we go deeper, please subscribe and like my channel. Let's dive into the details. Pipe material can be categorized into three main categories: metal, non-metal and lined or clad piping as illustrated in this chart. These are the normally used piping materials in the construction industry. Metal piping can be subdivided into ferrous and non-ferrous categories. Ferrous pipes are the ductile iron, cast iron, carbon steel, galvanized steel, black steel and stainless steel. Non-ferrous pipes consisting of alloy materials such as copper alloy, aluminum alloy, nickel alloy etc. On the other hand, non-metal piping including polyethylene, PVC, cement, fiber or glass reinforcement plastic. The lined or clad pipes are those piping lined with rubber, PTFE, FRP, glass and cement. Selection of the best piping material is a very challenging task and shall be carried out carefully. The important criteria of piping material selection will depend on the following: type of fluid being transport, temperature of fluid, design pressure, material properties, environment of piping, and cost of material. However, in today's session, I will only touch on the material properties, where the different type of material surface roughness and its impact on the pumping system. Surface roughness or roughness is defined as the irregularities which are inherent in the production process. Surface roughness is quantified by the deviations in the direction of the normal vector of a real surface from its ideal form. If these deviations are large, the surface is rough; if they are small, the surface is smooth. Different material has a different surface roughness. In a pumping system, the friction loss is the major head or energy loss where the pump is required to provide the energy to overcome it. Material roughness is an important factor in determining the system head loss. The higher the roughness, the greater the head loss and more pumping energy is required. The frictional loss is given by Darcy-Weisbach equation. And the friction factor, F, will be determined by the Colebrook-White formula. You can refer to my earlier video, How to Create System Characteristic Curves, in the link above for more details on the friction head loss. The pipe material roughness, E, can be found from the pipe material properties, which is normally provided by the pipe manufacturer based on the manufacturing process. However, authority may provide guidelines on the pipe material roughness to be used in the design calculations. This pipe roughness shall be used in the friction loss calculations when designing the system in order to complying with the authority requirements. The friction factor also can be determined using the Moody diagram with the known pipe roughness. With relative roughness and Reynolds number, the friction factor can be determined. I will illustrate the impact of roughness to the total pump head using the spreadsheet I had shared in my earlier video. Let's use the ductile iron pipe and compare the old and new pipe roughness. The pipe roughness is 0.1 mm and 0.3 mm for average and new pipe respectively. The remaining other parameters such as length, number of fittings and flow remained the same. The calculations result showing the total head of 36.1 meters and 34.4 meters for used and new pipe respectively to deliver 100 liter per second flow. From the calculations results, the new pipe pumping head is lower by 1.7 meters. Depending on the system characteristic, significant reduction of pumping energy can be seen if it is a larger and longer distance pumping system. However, other factors like the installation environment, type of fluid, temperature, pressure and etc. as mentioned above shall also be considered for the best pipe material selection. That's all for today. Thanks for watching. Please subscribe and like my channel if this video is helping. Hope to see you in my next video.